Hello everyone, welcome to today's video. So today's video is going to be about polynomials and we will see how to do this problem using the properties of polynomials. This is a very interesting problem and this kind of problems have been seen extensively in Olympiads. But for you people who are also preparing for JEE or ISI CMI, I also wanted to show this problem and to get you to learn about this from the very basics about how to solve this kind of problems involving polynomials which are not really quadratic. So you can see f is a fourth degree monic polynomial. Note the keyword monic. Monic means the leading coefficient is 1. So you have to note down that monic would mean that leading coefficient is 1. Now, what does that mean? That means that the polynomial which has the highest degree 4 in this case, that is, it will have a term x to the power 4. That term will have coefficient 1. So, leading coefficient is 1. Now, we are given the values f of 1 equals to 2, f of 2 equals to 3, f of 3 equals to 4, and f of 4 equals to 5. We have to find out the value of f of 5. Now, it might be interesting to note that this pattern does not actually give you the actual value. So, f of 5 need not be 6. Do not make this mistake because in mathematics, you do not really assume things without proving them. So, this pattern might seem very attractive to you, that why not follow the same pattern, but usually it does not work that way, right? And we are going to prove it. How? First of all, notice that the four values which we are given, f of 1, f of 2, f of 3 and f of 4, at least these four values confirm to a pattern, right? Now we will note that any fourth degree, so let's say I have any polynomial, right? It could be an nth degree polynomial. The fundamental theorem of algebra tells me that any polynomial which has nth degree will have exactly n roots, right? And it can be written in the factorized form. So any fourth degree polynomial can also be written like x minus alpha 1 into x minus alpha 2 into x minus alpha 3 into x minus alpha 4. And in the front, you add a constant c, which means the c is nothing but the leading coefficient of this polynomial, where alpha 1, alpha 2, alpha 3, and alpha 4 are the roots, correct? Now, this entire polynomial, which is of fourth degree, this is what we are given in this question, and we are given four such values. To make things easier for us, we will first assume a auxiliary polynomial. Okay, so let us say g of x is another polynomial, but this polynomial is different from f of x in a certain way. We are going to do g of x equals to f of x minus of x plus 1. Now, why do I have this only and only this choice, and why we cannot use any other way? First of all, notice that f of 1 is 2, f of 2 is 3, f of 3 is 4, f of 4 is 5, which would mean that this gx definition, the definition of g of x, implies that g of 1 is 0, doesn't it? So let us check g of 1. If I put x equals to 1, it would be equals to f of 1 minus 2, which is nothing but 0. In a similar way, if you check g of 2, this should be equals to f of 2 minus 3, which is 0. So f of 3 and f of 4 you can check similarly. G of 3 and g of 4 are going to be 0. Now, with this in mind, we can understand that g of x is a fourth degree polynomial as well, because we are only subtracting a linear term from f of x, which itself is a fourth degree polynomial, right? So g of x itself is a fourth degree polynomial, will have the same leading term as f of x, but we know that f of x is a monic polynomial, so the leading term, leading coefficient is only 1, which means this c is nothing but 1 in this case, correct? Now, g of x can also be factorized as the product of its roots using fundamental theorem of algebra. But we understand that g has roots 1, 2, 3 and 4 because similarly g of 3 and g of 4 are also equals to 0. And a fourth degree polynomial may have at most 4 roots, correct? This would mean that g of x can be written as x minus 1 into x minus 2 into x minus 3 into x minus 4. And the leading coefficient is 1, which means since f of x was a monic polynomial, g of x is also a monic fourth degree polynomial. Now, since we have g of x, we can put in the value of f of x minus x plus 1 in this equation, and now that would give us f of x minus of x plus 1 is equals to x minus 1 into x minus 2 into x minus 3 and multiplied by x minus 4. And therefore, we can write that f of x is equals to x plus 1 plus x minus 1 multiplied by x minus 2 times x minus 3 times x minus 4. Okay. Now, what do we have to find? We have to find f of 5. This seems like an easy task now. So, therefore, f of 5 is basically 6 plus 5 minus 1 into 5 minus 2 into 5 minus 3 times 5 minus 4. If you calculate this, this is 6 plus, now this is nothing but 4 into 3 into 2 into 1, which is 4 factorial, right? Which is 24, and 6 plus 24 is nothing but 30. And therefore, we have our answer. F of 5 is 30 and not indeed 6. So this is called interpolation. This is Lagrange's interpolation, and we have not used any sort of formulas for interpolation. Rather, we have only used our methods of basic algebra to get to this point. So that is why this is a very interesting type of question, and you can very well expect it in any high school examination, given that you have been already taught about polynomials and quadratic equations and roots. So if you like this video, let me know in the comment section. Please subscribe to this channel if you're new. And also for the courses, the scholarship test is going to be on the next week. So best of luck for that, because that will be the entrance to the ISICMI course and the J Advanced course as well. Thank you again. I'll see you in the next video.